Okay, it seems I've blown up my HiPot tester somehow. I was testing this air variable with some DC voltage as well as some AC voltage in an earlier video. And slowly but surely the DC output started degrading all the way down to now where it's only putting out about 70 or 80 volts DC. So the AC seems okay. It goes all the way up to about 6 kV. So I decided to tear it all apart. Kind of an interesting device, somewhat decently made. A nice variac in it for the voltage control up front. Really nice variac for being made in China, of course. A bunch of electronics, a bunch of chips, crystals and stuff. Pretty elaborate circuit boards in there. And up in there it looks like some switching transistors or maybe some power supply regulator. It's probably a little step-down transformer, but here's the main transformer. It's kind of a big potted thing. Yeah, it's kind of interesting. They have the voltages on the top, on the side of it. 1 and 2 is obviously the primary. That's these two here. The 3 and 4 ones aren't used. I think it's 3 and 4. 4 and 5, a 30-volt winding here, not used. And here's the high voltage one. So looks like 6 to 7 is a 3600 volt, and I think that's the one you use for DC, because I know DC was a little bit less than the AC. And 6 to 8 is the high voltage, the 5000 volts. So we can look at 6 to 8. So here's 6 to 8. Yeah, this is 8 here. It says down here 7 and 8. This one, pretty straightforward. That goes straight to the AC side. So that wire comes over to here. I'll use this as a pointer. So that wire comes up over here, and as you see, it goes straight out to the AC connector, which is this one here, the AC voltage one. And then what you see here, this is a resistor, high value resistor they're using for metering. You can see they got it all, it was all gooped up with RTV or some sort of a silicone gooey stuff here. It's dry, but it's just like rubber. But anyway, there's a resistor, and then you can see a smaller wire. That probably goes off to a metering circuit, so that's probably a really high value resistor. Just soldered and taped in there. So the DC side, a little bit more intricate. That's got to be this 3600 volt winding. 6 and 7. 7 is here, and that makes sense because it comes in on the bottom side here, right here. But what it does here, it looks like it goes through 2 power resistors, all grouped up in there. And it looks like it goes through a diode, which is what we'd expect for DC. And looks like it has some writing on it, some ratings. Even has a brand on there. I don't recognize the brand. But it's saying here 0.2 amps. So it's 200 milliamps at 20 kV. That should be plenty for this circuit if I didn't toast it. And then it has 2 more power resistors. Looks like they're stacked parallel on the outside. It's got some writing on the back side, but I just can't quite get to it. Back in there. Maybe we could see it with the phone, maybe not. I don't know, I just measure them. And then, then where it goes off here, this wire here goes off to the DC connector, which is on the right, and that's the one that's got low voltage. And again, we see another, looks like another power resistor that's glued up underneath this lead here. Just gooped up in there, probably real high value. And then there's an orange wire that probably goes up to the metering circuit to measure the DC voltage, which is what that switch probably is, which is you see DC voltage on the meter. So what I don't understand is this capacitor. It's 15 kV, this big white thing here. 2 leads, 1 lead in, comes off this center, this transformer. I guess it's a secondary, or not the secondary, but the common for that winding, because the label says 3500 volts from here to here, and 5000 volts from here to the bottom one. And so the white one goes up to the circuit board. Don't know what that does. Capacitor, probably some sort of a voltage doubler, or maybe just a filter, I think in this case, or just a coupling capacitor of some sort. Maybe it's a high frequency transformer. Don't know. But anyway, it comes in here, and it looks like it hits right on the other side of that. It's almost like a filter capacitor maybe for the high voltage, or for the DC side, I should say. So winding 8 comes in here through the resistors, through the diode, more resistors into the output, and then this 7, which goes to that capacitor, is this wire back here. So not sure what that one does. So I'm going to have to do some troubleshooting. One of these components got soggy or saggy or something. But the interesting thing is, if 5,000 volts for the AC is here, and according to this transformer, that's between 6 and 8, and 8 only goes through, here's 6 here, and that black wire only goes through the capacitor. So I'm wondering where the return path is for this lead, the AC lead for 5,000 volts, because it looks like the capacitor, now this is the lead for 5,000 volts. The lead for the capacitor comes in here and looks like only goes to the DC side. So I don't see how he goes to ground or anything like that, unless this white wire somehow makes itself to ground, chassis ground or something like that, which could be very well. In fact, which case this is probably just a filter cap if that goes to ground. And I could take the meter and measure that. So what I'm going to do is I'm going to dig out some of these resistors. I have some really, really sharp probes. I know I bought them at a Handfast or a swap meet or online or something years ago. But super sharp. These needles are needles. So that'll be perfect for diving into there. I'll plug that into my voltmeter, do some troubleshooting, and hopefully I can find the problem. I doubt I got replacement parts, but it's not the end of the world if the DC doesn't work. I mean, worst case, I can build another rectifier for the AC and get higher voltage on the DC side or something. So, okay, wish me luck.